I might use the calculator to simplify this. Like if you type 6 divided by 9, it'll simplify it for you immediately. So hit the little calculator, hit escape, go here to the scratch pad, and do 6 divided by 9. So clear that out. And delete one more time. So do 6 divided by 9. Hit enter. Well, 2/3. 2 divided by 9. Be careful with that. We're going to talk about y in a second. 2/3. Okay. So we have some notes on equations for lines. Let's get that out and use those. My bad. Emily, don't forget to plug your phone. To be a linear equation, yes, it has to have an equal sign.
You be sitting weird. Why you be sitting like that?
Hey, Jordan.
No, but they said a check in our English, so you can't see it. So you get up at the season saying real check English, but you looking at me talking?
Hey, Jerry. Trent, no phone, right? Still no phone? There's some on the short that's all Thank you. Thank you. Thank you. So let's go over this. I'm going to talk about a couple of things from what I'm hearing y'all talk about. And I need y'all to hear me on something. One of the reasons why I'm asking y'all to actively collaborate on the math is you may not realize it, but as y'all are talking in your small groups, I can listen in on your conversations and hear where we're struggling so that I can give you better support. Whenever I have a whole class discussion, it's based on the mistakes that I hear people make so that you can fix those mistakes, and it's based on what we need to know to be successful. So when I'm at the board, take notes on this. So here's a couple of things that I want to point out. All right? I saw some people do this very successfully. When we are trying to write this equation, do you know what the very first thing you should do is? Good. I need y'all to pay attention to this. When we are trying to write an equation for the line, write out the equation first. Pay attention. Because, anybody know? Yes? Hello? I haven't heard you yet. Hello?
Yeah, bro.
You're checking out, right? That's probably what that is. It's not time yet? I'll wait for the Okay. Y equals mx plus b. And so, look at that first response up there. Anybody know what the 2/3 was someone was trying to do, or a group was trying to do? Well, they were probably were they trying to give us the equation of a line? What were they trying to give us? The slope. If I see just that 2/3, my guess is they were trying to find the slope. Be careful and read the directions because it says write an equation. I don't have an equation with that one. I want y equals mx plus b. And if you write down the equation of a line first, that should give you a hint into what to do next. What do we need to do next? Slope, and how do we calculate slope? Okay, so two things really quickly. Why did I hear that chime? Huh? Okay. So, be careful. I need y'all to hear me very clearly on this. I know it doesn't matter to you right now, but it will matter to you in future math classes. The word over does not have any mathematical significance unless it's talking about reflections. What is this mathematical operation? Division. So don't say overrun, it's rise divided by run. Or, and some people have already been saying it, the change in y divided by the change in x. I know that that's uncomfortable language because we're not used to it, but I promise you it's going to help you long term. So n is equal to rise divided by run, or change in y divided by change in x. That's going to be a focal point for me to get started. I'm going to go to the graph now. And how am I going to figure out what the slope is off of a graph? Alright, just find points. Does it matter which two? No, I just need 2 points, right? So here's a point, here's a point, here's a point, here's a point, here's a point. Can I get somebody to come up here and show us the rise divided by the run? Nathan, come on up. Okay. Not you yet? Oh, you found it. Yeah. All right. Can I see that really quickly? So, does anybody want to add on to what Nathan wrote up here or push back in any way, shape, or form? Okay. So what would the slope based on that information be? My rise would be?
2 over 3.
Divided by
3.
I need y'all to pause and I need you to look at this again. If the slope is positive, is that line increasing or decreasing? The line's increasing. Is that line increasing? It's decreasing. I need y'all to pay attention to this. When you read a graph, you read it just like a book. You read it from left to right. You don't have to do this. What Nathan did is okay, but I probably would have started maybe with this point and gone to the right. It helps me focus my attention. But I would point this out. If all you're doing is drawing a triangle there, that's actually not going to help you as much in finding the slope. He drew a line here, right? Mm-hmm. Is that going up or down? Could you put a little arrow there to show that? And if it's going up, is that adding to or negative or subtracting to? Adding. Then he went to the right. There's an arrow. If it's to the left, is that adding 3 or subtracting 3? Now when I look at my slope, it's 2 divided by negative 3, or negative 2/3. Does that slope make sense looking at this graph? Yes. Okay. So that's a small thing, adding those arrows there to help you think through if you're adding or subtracting to make this make a little bit more sense. All right, from there. So remember how I mentioned going from left to right? What I probably would have done is maybe go from here. I could have gone, notice that's down, right? How far did I just go down?
4.
Down 4? Then I would get to this point. How far did I go to the right? So adding or subtracting 6? Notice how I have those directions in there to help me identify adding and subtracting. Okay? And that's going to help you identify the slope. I think some of us went from the y-intercept all the way down to the, what's that point called? X-intercept, right? That would have been perfectly fine as well. But regardless, right, if I do negative 4 divided by 6, anybody know what that would become? Negative 2/3. Okay? So I do want to point this out really quickly. If you're on a page like this where you have a question and you need to do a calculation, remember there's this little button between escape and tab, and it looks like a little calculator. It brings up the scratch pad. And on the scratch pad you can do calculations. Negative 4 divided by 6. Whoops. Negative, no, I just want a negative. Negative 4 divided by 6. Negative 2/3. Notice if I don't put a decimal in there, it doesn't give it to me as a decimal, it gives it to me as a fraction, which is what we would ideally want. Okay? Huh? Negative 4 divided by 6. Well, you don't have to simplify it by hand. Remember, that's what I just showed you on the calculator. The calculator did it for me. That's why I would recommend simplifying it. You go to the scratch pad, you type in that negative 4 divided by 6, the calculator does it for you. So if I ever want you to simplify it, you will have a calculator to simplify it for you. Okay? Now I want us to look at a couple of things from here though. We're not even quite done yet, we're just on the slope. So now I have y equals, what's being substituted in for m? Negative 2/3. Notice it's decreasing. X. What's that b? The y-intercept, so plus 6. One of the most common things I see students do, and I see students here who did it, look at that third equation. What's that completely missing? The x. Don't you kind of need x to have the equation of a line? But look, if you were to write out y equals mx plus b, and you were to put, okay, so m is negative 2/3, there's my x, and there's my b, wouldn't that help you focus your attention to make sure you don't miss that x? And it's important. If I were to pick up a calculator and I were to type in, no, that's not what I want. Hold on one second. If I were to go to graph, and I were to type in 6 divided by 9 plus 6, well, that's going to be up here. Does that give me the line that I wanted? No. Okay? I thought, did I never pull that up earlier?
No.
Hold on one second, sorry. Share my screen. There we go. So note, that's not the line that I want. You have to have the x in there. Now notice if I put an x here, is that the line that I want? You sure about that? What's wrong? What's positive? The slope was positive. If I put a negative in there, does that give me the correct graph? Yes. Okay. So you got to be careful. You got to have the x. You got to pay attention to the negative to make sure you get it right. Now, I do want to point this out. For those of y'all who don't love all of this work, there is a slightly easier way. Did I ever say that you had to stay as a graph? For everyone who drew the graph on their own, what other representation could you have created? A table. And if we want the equation of a line, I definitely want what point? What point do I want though? Hey guys, what point do I need to write this equation? I heard someone say it. The y-intercept, right? If I want to write this equation, I definitely want the y-intercept. Okay, 0, 6. What's any other point that I could pull off of this graph? Say a point on this graph. 6, 2. Now look at the y. To go from 6 to 2, what's happening? Subtracting 4. To go from 0 to 6. So remember, m is the change in y divided by the change in x. Negative 4 divided by 6, or negative 2/3. And then there's my y-intercept right there. Notice the table is actually easier than a graph because you have less work to do in actually creating it. They both give us the same equation though, don't they? Y equals slope of negative 2/3 x plus the y-intercept of 6. Okay? And so I just want you to notice, right? We need to know how to write the equation of a line, and we need to be aware of those different representations. So we'll finish writing those notes. If you haven't already, I'm going to talk about one last thing with lines before we get started with today. Now, I need you all to pay attention to this information. That's a process, that's a procedure to be able to get the equation of a line. But I need to talk today about what is a line. Because what we're doing right now is we're looking at bivariate data. We're making predictions about points based on a trend line. So what is a line? What makes a line a line?
It's never ending.
Okay, it's never ending, but that's a good point. But what about this? That never ends. Is that a line?
No.
No?
I forgot.
Point.
Arrow.
Say again. Points. But again, I'll point this out. This has points on it, doesn't it? So is that a line? No. Okay, so it needs to be straight. It needs to have a line there. Okay, but I want to point this out. You see this table?
Yeah.
Okay, so this table is based on these points for this line. These points that are in pink represent that line, okay? Anybody see any pattern in the y values? They're what? Being subtracted by 2? Anybody see a pattern in the x values? It's adding by 3? So what is being repeatedly done in a linear function? It's being added. I need you to hear me very clearly on this. To understand linear functions, because you did them some in 8th grade, you're going to do them a whole lot in Algebra 1, and we're going to deal with them some today. What makes a line is what's called a constant additive rate of change. So lines are lines because of a constant additive rate of change. And someone already mentioned this earlier, but does anyone know what the name of that constant additive rate of change is? Okay, I'm going to wait a second until I see everyone done taking notes. Hey Wesley, you awake over there, buddy? It's hard to learn with our heads down. Brooklyn, you awake? The answer is no, she is out cold, Mr. Kinney. Cool. Jane, you got all this down? You got that table and stuff? You got the notes about lines are lines because of the constant additive rate of change? Okay. I want you to note right here, this -2. We talked about that already. That's the what? Just the -2. Ah, that -2 is the change in y. What's that +3? The change in x. So we see a constant additive rate of change there. Change in y is -2, the change in x is +3. Where does that change in y and change in x come up? So the constant additive rate of change is called the slope. Y'all talked about slope, and most of y'all probably already know that slope is what's defining the line, but why is it? Because the slope is the constant additive rate of change. Lines are lines because of a constant additive rate of change called slope. That slope is critical to understanding lines in their entirety. And that idea of slope is going to show up throughout the rest of this semester. That idea of slope and that constant additive rate of change will show up throughout the rest of this semester. Okay. What are your questions before we get back to the lesson? Doesn't sound like we have any. Alright, so I'm redistributing the lesson from yesterday, or the files from yesterday. I'm sending the missing files. Okay, so you should have gotten the file to your calculator. Wesley, you awake over there, buddy? Wesley, you got it? The file? Okay. Alright. So you should, well, here's our agenda. Right, we're gonna, it's not the initial look, we're gonna keep looking at bivariate data. We're gonna finish up squared up and then get back to the lessons from the book today. And so you should have this squared up task out on your desk. You need your squared up task out on your desk. Did you open the file that I sent? Go to Browse. Go to Geometry. Dude, you never logged in. There's no way because it still has that symbol on the top right. See your pencil? When it has that symbol on the top right, you need to reset the calculator. And so you should have gotten the file back that you had yesterday. Jordan, you cannot learn with your head down like that. Absolutely no way. Brooklyn, you cannot learn. Brooklyn, you cannot learn when you have your head down. All right. Okay. So this is where we are, where we ended yesterday. We talked about the idea of residuals. What did we talk about with residuals, just as a quick recap? Okay, so it's the distance from the actual point and the line, which the line represents all of the what? Predicted values, right? So remember, we're going to have those data points, we're going to have a trend line, and so the residual is the difference between the actual value and the predicted value. So if the actual value, the point, is above the line, the residual was what? Guys, if the actual point, so I'm just making up a sketch here, but if I have an actual point here, and I have a trend line here, here's my actual value. It's above the line. The residual is going to be positive. We got to recognize that residual will be positive. For these below the line, remember the residual is that straight line right here. That residual is going to be negative. And if I have the best trend line, some are going to be positive, some are going to be negative residuals, and there's some's going to be, some is going to be neutral, which is 0. Right, Thomas? The idea of neutral is 0. Okay? So if we add up all those positives and negatives, we get a 0. But we don't want 0, because it'll always be 0. So we need to find, what did we do to the positives and the negatives, those residuals? What we ended yesterday with.
We found it.
1031.5.
Hold up. Let me pull it up. What did we do? Remember, I don't just have residuals, right? Residual is just that straight line. What do we have here? We have the squares, right? We took each of those residuals and we squared it, because if I square something, what's that going to make that number?
Positive.
Positive. So that when I get a sum of squares, it's not going to be that negative values, that you're not going to have those negatives in there. And so where we are right now is this part. Nope, not that part. Is this page right here, or these questions, where it says find a least squares regression line. With a least squares regression line, we want to make that sum of squares what? We want to make it small, right? So we did this yesterday. We played around with that line. We started manipulating it. Keep manipulating it right now to see if you can find the lowest sum of squares, right? So we can rotate and we can translate until we get the lowest sum of squares possible. So work, talk with each other, but try to move that line around to make the lowest sum of squares possible. Remember, where does the cursor need to be to translate it up and down? Where on the line though? In the center, right? To translate up and down, you need that cursor in the middle. To rotate it, to change the slope, you need the cursor on the top or bottom, like the ends, okay? Hey, Brooklyn, how are you going to learn? You just praying that you're going to pass my class? Okay, well that's not going to happen. You got to learn something. Come on. I'm here to help you learn, but you can't do that if you're not trying. Okay, cool. Good talk. Coda? And by the way, guys, y'all can, once you have an answer, write the answer down on a sheet of paper, work with each other, check in with each other. Well, that's the one you're on actually right now. Play around with it. You think that's the smallest sum of squares you can find? You got 130? You want to go find something smaller too. I guarantee you can. What's going on? I'll hope that you minimize your sum squares. So, do you remember what one button we pressed to do pretty much everything in this calculator? And by the way, it has no directions on here, but analyze, loop. No, it's going to be easier, just set that. Okay, escape from there, get rid of that. Okay, so go to menu, analyze, nope, add movable line first. Ooh, you can get smaller than that. Alright, so hit menu now, analyze again, and you're going to add residuals. Just hit the number sign. Go. And show your residual squares. Man, you started out with 160, so you can definitely get below 310. Those squares are huge.
Ooh, Miss King.
That's because when it was
Sum of squares, 49. I got one.
Thank you. Thank you. I need you to show y'all a couple of things that can help you fix stuff if you mess up. One, Control Z. You can hit the control button and hit Z, and it will undo the last operation that you did. So this is the same thing on computers. If you hit control and then Z, it undoes the last operation you did. Now I need y'all all to pay attention to me on this, because some of us royally messed up our lines and we need to start back over. So, what's the one button we press on these calculators to make everything happen?
Menu.
Menu. If you go to Actions, uh-oh, never mind, that's not even under this action. Hold up. Well, you may just have to create a new graph. If you messed up, okay, hit Control and Dock, and it's going to allow you to add a new page. If you messed up, you don't have to do this, but if you mess things up, hit Control Dock to add a new page. What kind of page would you need to add? Data and statistics is where we have been. Notice this is exactly what we started out with. What was supposed to be on the x-axis? Thought it was year on the x. And on the y? Person. Right? Being their life expectancy. And you can go back through the directions. So how did we add that movable line? Menu, analyze, add movable line. What do we still need? The squares. So I need to go back to menu, residuals, and residual squares. For all of y'all who are like, man, 210 is the smallest it can get, y'all, it starts you out with 163. And I can guarantee you, you can get smaller. You got all the way down to 48. So there's a challenge. Play around with it some more until you can at least get into the 40s for those sum of squares. Okay? You don't have to get to 40, but you should get lower than 100 for sure. Please note, once you get your line, move on to numbers 5 through 9. You don't need me to answer those questions 5 through 9. Brooklyn, you don't have this, do you? I promise you can't. Hey guys, look. Well, first off, you gotta show squares, right? You just did. Look, right here. Hey, nice. Remember. Hey, by the way, guys, remember you can translate it and rotate it. So you need to play around with both the translation feature and also the rotation feature. Just a couple of things. So you need to both translate and rotate. Oh, Brooklyn, I gave this out last Thursday or Friday. Check in your notebook for it. Remember, you're trying to make those squares as small as possible, right? You're making these squares smaller. Keep going up. You're making those squares smaller, but you see how those are getting bigger? So translate it up and then try to rotate it.
I don't even know how to go back there.
Stop. So rotate it. Need that symbol. You see that symbol there? You go, hold it down, now rotate. Crazy. Getting smaller now. Under 100. Keep playing around with it until you can minimize those squares. Okay, you start answering those questions. Guys, once you have your best answer, start answering questions 4 through 9. Dog, why you got so many lines there?
Okay, no. When I had one line in the middle.
Remember when I said just add a new page? Do you not remember when I said to do this? If you really messed up? So then why didn't you do it? Because what? There you go. Alright, we need to start answering 4 through 9. Play around with it a little bit. Yes, sir.
I was at 45, but.
So here, do this over. Hit Control D. Okay, so 46, maybe. No, go back. So just go to current. 46. Fine.
But what is this like above?
So those two are below, those two are slightly above, those are above, and then all those are below.
How did I get it? How did I get it? I got the same answer you got.
Check here.
I got 60.
Oh, back in the new one.
Yeah, so notice it's 2000, 2004.
You said the lowest you can go.
Does y'all have it in your book?
You go over 41. You see? You got 41, I got 45.
Have you started answering the questions? Guys, at this point, move to questions 4 through 9.
Yeah, I got 60.
I got 41.
Okay, move on to your questions on the count, or the questions 4 through 9. I cannot emphasize that enough.
Yo, bro. The higher you go, I didn't say that. Somebody
Roseland, you're with us. It's right there. Guys, have y'all started answering? We're trying to make the squares as small as possible. You've got 2,000.
That way? But I had 80 shit on hours. Hell, we already put it in. Because I don't know which one. I'm asking. I'm asking.
Now,
I was asking which
square right there. Maybe I'm moving this up.
I was asking her which one she was talking about. I was pointing out.
Oh, and then let's try to rotate it again, so.
I didn't mean to point at you. I got 80, but I don't know.
Oh, there's 61. You see how you're getting those points well? But you're kind of far off from those. So come here and translate it now up.
Yeah.
Who's smelling?
Oh, I got it.
41? Alright. Let's pause and let's look up here, guys. Hey, shh. Listen, we're about to start answering those questions together, but I want to point this out for those of y'all who didn't pick this up. Eyes up on the board, please. Me just doing one transformation, was that enough to minimize?
No.
No, I'm at 160 right now. I'm going to try to rotate a little bit to get closer. All right, down to 115. Is that really getting all these points pretty well, though?
No.
No? So what do I probably need to do now?
Move it.
Move it up? Translate it up?
Yeah.
All right, that's a little bit better, but now see how I'm really far away from these top points? So what do I need to do?
Move it.
Rotate it. Notice it's not going to happen perfectly right away, but dang, that's 66. All right, I'm going to translate up some more. Okay, I'm up to 87. Let's rotate again. 58, 47. Down to 46. I'm going back up, so I'm going to translate up some more. Down to 44 now. Let's try translating up a little bit more. Oh, get further away. Hey, 41.4. Anybody beat that?
Yes.
Good job. The point really though is, and what I want you to see, is it takes practice and it takes playing with it. You're not going to get it right away from one attempt. You got to play around with these things. But let's look at the questions, because the questions are what are really going to help us focus our attention. All right, so my smallest size was 41. Write down whatever your smallest value for the sum of squares was. But let's look at this together, all right? I'm going to call in a few different students. Devin, when you looked, how many points are above your line and how many points are below your line? Okay, so for Devin, you got 5 where? 5 above? Okay, so I've got Devin, hold on one second. 5 are above. How many below? How many? 6? Sure about that? Hey, do y'all know how many points are there? Huh?
8.
Okay, really quickly. Hey guys, anybody know where you could go to find out how many points there are total?
Yes.
Not many. Hey, aren't these points based on the table that's on 1.2? Oh, how many points are there? Say, I thought it was 15. There's 15. Because look, it goes from 1900 to 2000 by what? 1900 to 2000 by how many years? Tens, and then 2001, 2, 3, 4. So there's 15 data points. How many did Devin identify? 11. Okay, look. Part of the reason why we're missing it, does anybody know how many data points are right here?
No.
Remember, that's 2001, or 2000 to 2004. So that's how many? 2000, 2001, 2002, 2003, 2004. You didn't forgot that 0, right? So there's 5 up there at the top. So Devin, how many do you have above and how many do you have below? How many above? There's no way. There's 15 data points, Devin. Devin. Hey, Devin, look. Were you paying attention when we said that there's 5 points right here?
Yeah, it was you did.
So you counted 5 here. 7 then?
Yeah, I was trying to write my fault.
Okay, that's still only how many points?
12.
12. Well, how many do we need? 3 more. So keep looking. Somebody else who has all 15 of their points. Emily, what you got?
8 above, 7 below.
8 above, 7 below.
I had 6 above, 9 below.
Okay, so you had none below? What was your sum of squares though? 100? So could we have probably made those sum of squares a little bit smaller? Okay. Peyton, how many points do you have above and below? You have how many?
I said, mine not right. I already did it, and the number had got to do it, so.
Okay. Remember, you can hit Control Z to undo that. Try to fix it then. Coda, how many you got above and below?
I got 8 above and 7 below.
8 above and 7 below. All right. Thomas, how many you got above and below?
6 above,
6 above and
9 below.
9 below. Does anybody notice, and let's actually look up here. So I've got 1, 2, that's barely below, but it's a little bit below. That's 3, and that's 5 up there for a total of 8. I've got 8 below, and I've got 1, 2, 3, 4, 5, 6, I'm going to say 7 above. So if you are creating the best trend line, the trend line that has the smallest sum of squares, how many of the points need to be above and how many need to be below? The same amount. Because notice we only have 15 here, but if I had 20 data points, how many should be above and how many should be below? 10 and 10. If I had 100 data points to Marlon, how many points should be above and how many should be below? 50 and 50? Everybody agree with that idea? Okay. So, what should we put here, right? And so you should have 5, 6, and 7 written down. So write down how many points you have above and below. Check with a partner, so copy down one of these. I think this was Thomas, I think this was Coda, and this was Mr. Kenny. Alright? So pick one of those to put under number 7. So get your answers down for 5 through 7 before we get going again. Caitlin, have you answered 5 through 7? You can't huff and puff when you're not doing what I asked you to do. That's my job at that point.
Mr. Green, can you help me with 6 and 7?
1, 2, 3, 4, 5, 6, 7 or above. That's 5, 6, 7, 8 below. Ezra, what's your question, bro?
Can you help me with 6 and 7?
Buddy, the answer for 6 is based on your graph, and pick any of these up here for number 7. I can't tell you the answer because you didn't do what you're supposed to do on the calculator yet. Not all. You sat there and chose not to do what I asked you to do, bud. Excuse me? Okay, so you need to have your answers down.
No.
So does anybody know which data points are increasing the sum of squares the most? Where do those occur in the data? Anybody know? Anybody see which points are increasing the sum of squares the most right now?
Middle.
Which ones? The ones in the middle? Why are these the ones that are increasing the sum of squares the most?
Because they're the biggest.
Because they're the biggest squares, right? But why are those the biggest squares?
They have the most.
It's not more data. It's the same. Each point is one data point, right? Look, how are we getting these squares? From what? Starts with an R. Residuals?
Residuals.
And the residual is the distance from the point to the...
Oh, because it's higher.
Oh, because it's further away from the line, the predicted line, right? Notice the ones that add the most are the ones that are furthest from the predicted line. So like right now, look at this graph. Which points are going to add the most to the sum of squares? Not the ones in the middle. Those are not adding much to the sum of squares at all. See how those are the points furthest from the predicted line? The ones furthest from the predicted line are the ones that are going to increase the sum of squares the most. So which data points increase the sum of squares the most? The ones furthest. The ones furthest from the predicted line. How do the size of these squares compare to the others? They're what?
They're bigger.
They're way bigger, right? The further a point is from the trend line, the bigger the square is. That's why it increases the sum of squares. The further the points are from the trend line, the bigger the square. So the further the points are from the trend line, the bigger the square. That's important to note. What are your questions at this point? You need to start putting your watch up too, so it's not distracting. Okay. All right, I'm going to leave that note up there, but I'm going to move to this next slide. So here's the thing, and we already talked about this. So what should we notice about the distribution of the data points around the line? What's above versus what's below, or equal spacing versus clusters? What did we already say about the points above and below? Say it left. Well, yeah, so the ones above are going to have a positive residual, and the ones below are going to have a negative residual. But what I'm talking about is what did we notice about the points above and below?
They need to be equal.
So they need to be evenly distributed around the line, right? So there needs to be an equal number above and below. Okay? And so to have the smallest sum, and this is really what we want to focus on, to have the smallest sum, how do the points need to be distributed? It needs to be evenly about the line, and the points need to be close or far from the line?
Close.
Close to the line. That's what we want to notice to get to this final answer, to have the least squares regression line. The points need to be evenly distributed around the line. Right? They need to be evenly distributed around the line, and they also need to be close to the line. To have the least squares regression line, your points need to be evenly distributed about the line and close to the line. Say again, Anaya? Say again.
10.
10? That's this idea of them need to be evenly above and below. The focus, look, even if you don't answer number 10, it's fine. Number 11 is the focus. Those points need to be evenly distributed around the line, meaning above and below. And they need to be close to the line.
Understanding, like, if we need an exact number,
I'm going to look at what you're saying in a second. Okay. Now, just pause for a second. Did we all have exactly the same lines? There's no way. We had different sum of squares, right? Now, did some of y'all get equations that were close to mine of 0.267x minus 455? Did we get something close to that? Yeah. All right. And so we're looking at those sum of squares, but here's what we want to look at right now is at the next set of questions, number 12. There is a least squares regression line, the absolute best one, and your calculator can tell you what it is right away. Follow the directions that are on the paper, right? From the menu options, choose Analyze, Regression, Show Linear, MX plus B. And show the residual squares again. And answer the questions. So within your small groups, follow those directions above number 12 and answer those questions. I'll be more than happy to help. You never found it, did you? Brooklyn, did it ever pop up on your calculator? It did pop up on your calculator? There you go. Have you followed the directions? Okay. Have you started answering those questions then? Did you check in with Addison and see if she was in it? Hold on. You shouldn't have that many lines on here. I'm gonna add a page. Just to make it easier. Hey, Jordan, you're not in that group, don't talk to them. Gentlemen, start talking about your math. Come on.
We are.
Okay. We're not just stretching over there. You need to stay over here. Okay. So follow the directions to do that part. Have we all gotten the answer? Did it not show your sum of squares? There. Hey guys, please make sure you follow directions. Some of y'all are not getting all the information that you need to because you didn't follow the last step of show residual squares. Choose show residual squares again after you finish all of that. Yes. Have you done your regression? Then you analyze residuals, show residuals. There it is. That's your sum of squares. 2 or 3 decimal places. James, you haven't even started to follow the directions here above number 12. Come on. Stop in your group if you need to. I'll be back to check on it. Hey, go check on each other, make sure we all have. So, what you know is what is the value of the sum of squares? What should we all have gotten? Alright, so write that down. So, start working through the rest of these questions, y'all. So, remember menu, analyze, there's an option to show residuals. Yeah, you need to do your regression line and then show all that as well. What is your... What's your calculator? I don't know what you did there. Show me again how you got the least squares regression line. Guys, stop. Answer your questions. I'll come and check in a second. Answer questions. Have you followed these directions?
What are you talking about?
Okay. Now, all of that next sentence, right? Also choose show residual squares. So I need us to work with each other, learn and grow.